Welcome back for another deep dive.
Yeah.
Today, we are going to be tackling the foundational concepts of building data-intensive applications,
Cool.
as laid out in Chapter 1 of Designing Data-Intensive Applications.
Sounds good.
And, think about it, like all those apps and services that we use every single day,
Right.
from social media to online banking and all that, they're powered by these really complex systems that are working behind the scenes.
For sure.
And, really understanding the core principles, I think, can really change how we view this digital world that we're living in.
Yeah, it's true. We often take these systems for granted, but they're marvels of engineering. They're designed to handle just immense amounts of data and traffic
Oh, yeah.
while remaining reliable, scalable, and maintainable.
It's crazy.
And Chapter 1 does a really good job of introducing those three pillars.
Okay, cool. So let's unpack these pillars a little bit.
Yeah.
Starting with reliability.
Okay.
I think, everyone has had the experience of a website crashing or an app freezing up
Oh, absolutely.
at just like the worst possible moment.
At the worst time.
It's so frustrating.
Yeah.
So how do we make sure that these systems don't crumble under pressure?
Well, you have to design for failure.
Okay.
Not if things go wrong, but when hard
Okay.
drives crash, networks get congested.
Yeah.
Even cosmic rays can flip bits.
Really? I didn't know that.
Yeah. So the system needs to be what we call fault tolerant.
Okay, fault tolerant. So it's not about preventing like every single possible issue,
Right.
but about having like backup plans in place.
Exactly. A great example is the idea of a consensus algorithm.
Okay.
So imagine multiple servers all agreeing on the system state,
Mm-hmm.
and if one of those servers goes down, the others can seamlessly take over.
Wow.
There's no single point of failure.
That's really fascinating. It's like a safety net built right into the system's DNA.
Yeah.
But reliability, I mean, it's not just about preventing those crashes, right?
Right.
It's also about how the system handles errors
Yes.
and keeps the user experience smooth.
Absolutely. Think about those error messages that you see on websites.
Uh-huh.
A well-designed system will not only try to avoid those errors in the first place,
Right.
but also provide clear and helpful information to the user if those errors do occur.
Okay.
And then kind of behind the scenes, there's this whole world of monitoring and logging happening
Oh, wow.
to catch those potential problems before they become major issues.
So even when we don't see it, there's a team of like digital mechanics constantly checking the engine, making sure everything is running smoothly.
Yeah, working behind the scenes.
All right, so we've covered reliability.
Yes.
But what happens when our app suddenly becomes the next big thing?
Right.
How do we make sure that it can handle like this massive influx of users
Mm-hmm.
without slowing down or crashing? That's where scalability comes in.
Right. Imagine you're building the next big social media platform. You need to be able to handle millions of users.
Yeah.
Joining, sharing, interacting all at the same time.
It's a lot.
And there are two main approaches to scalability, scaling up and scaling out.
Okay, so scaling up, is that like upgrading to a supercomputer?
It can be. Think about upgrading your computer's hardware to handle more demanding games or something.
Right.
You're giving that existing machine more muscle,
More power.
more power, exactly.
Okay.
But for truly massive growth, you often need to scale out.
Okay, so what does scaling out look like?
It's like building a city.
Okay.
As the population grows, you don't just build one giant skyscraper.
Okay.
You add more buildings, more infrastructure to spread out that demand.
Right.
In a data-intensive application, scaling out means adding more servers and distributing the workload across them.
Ah, so instead of one giant machine, you create like a network of interconnected systems, each handling part of the load.
Exactly.
That makes sense.
Yeah.
But wouldn't managing a distributed system be way more complex?
It definitely adds complexity, yeah. You have to think about how data is stored and accessed across multiple machines,
Right.
how to handle the communication between those servers,
Mm-hmm.
and how to ensure consistency across the entire system.
Wow, okay.
But the flexibility and power it offers can be a game changer for handling rapid growth.
For sure. Speaking of flexibility, the book also mentions this concept of elasticity.
Yes.
What is that all about? Is it like a superpowered form of scaling?
Yeah, you could think about it that way. Elasticity takes scaling to the next level
Okay.
by allowing a system to automatically adjust its resources based on demand.
Oh, okay.
Imagine a balloon, right?
Okay.
When you blow more air into it, it expands.
Yeah?
When you let some air out, it shrinks back down.
Okay.
An elastic system can scale up or down on the fly,
Wow.
depending on how much traffic it's getting at any given moment.
So it's about being super efficient with those resources.
Yes,
Not wasting resources when demand is low, but being ready to handle those sudden spike.
exactly.
That's pretty slick. Okay, so we've tackled reliability and scalability, the dynamic duo of robust systems.
Yeah.
But There is a third pillar mentioned in the book,
Right.
maintainability. Why is that so important?
Think of it this way. Building a data-intensive application is like constructing a skyscraper.
Okay.
You don't just build it and walk away. You need to maintain it,
Yeah.
update it,
Right.
adapt it over time.
Yeah, for sure.
Maintainability is about making sure that that system can be easily modified, updated, and debugged
Yeah.
without causing major headaches for the developers.
Yeah, because let's be real, technology is constantly evolving.
Absolutely.
And user expectations are always changing.
Right.
So how do we design a system that can gracefully adapt to those changes without turning into like a Frankenstein's monster of code?
Well, the book highlights 3 key aspects of maintainability.
Okay.
Operability, simplicity, and evolvability.
Okay.
Let's start with opportunity. Imagine the dashboard of a car. A well-designed dashboard gives you all the information you need to keep the car running smoothly.
Right.
Operability is about providing that same level of insight into a data-intensive application.
So it's about having clear visibility into what's happening within the system.
Yes.
You can quickly identify and address any issues.
Exactly. Clear logs, monitoring tools, and alerts
Okay.
are all essential for good opportunity.
So it's like having a team of digital mechanics with X-ray vision into the system.
Exactly. You got it.
Awesome. That makes a lot of sense.
Yeah.
Next up is simplicity.
Yes.
Why is it so important to keep things simple in a system that's inherently complex?
Imagine trying to find something in a cluttered room
Oh, yeah.
versus a tiny, organized room. Which one would be easier?
Definitely the tiny room. No one wants to wade through a mountain of, like, digital clutter.
Exactly. The simpler the system's design, the easier it is for developers to understand it,
Okay.
debug it, and modify it.
Okay.
Cleaner code, fewer bugs, less frustration all around.
Makes sense.
It's a win-win.
So simplicity is really about making the system easier to work with in the long run,
Yes.
which ultimately benefits everyone.
Yeah, absolutely.
And finally, we have evolvability.
Yes.
Why is it important to design systems with evolvability in mind? Is it about, like, predicting the future of tech?
Well, maybe not predicting the future exactly.
Okay.
But it's definitely about anticipating change.
Okay.
New features, new technologies, new user expectations. These are constants in the tech world.
Yeah, for sure.
A system that's not designed to evolve will quickly become outdated.
Right.
And difficult to maintain.
It'll be obsolete.
Exactly. Think of it like trying to add a swimming pool to a house that wasn't designed for one.
Oh, okay.
It's going to be a really messy and expensive retrofit.
So evolvability is about building in that capacity for change from the start.
Exactly.
Like designing a house with the option to, like, add a pool later on.
Exactly. Modular design is a key concept here.
Okay.
It's about breaking the system down into smaller, independent components
Mm-hmm.
that can be easily modified or replaced
Okay.
without affecting the entire structure.
Gotcha.
Think of it like building with Lego blocks.
We like that.
You can easily swap out pieces or add new ones without having to rebuild the whole thing from scratch.
That's a great analogy.
Yeah.
And that kind of flexibility is essential for systems that need to keep up with this, like, ever-accelerating pace of innovation.
Right, absolutely.
So to recap, we've talked about reliability,
Yes.
making sure our systems don't crash and burn,
Right.
scalability, ensuring they can grow with demand like a digital city,
Yes.
and maintainability, keeping them adaptable and easy to work with like a well-organized Lego masterpiece.
I like that.
These aren't just buzzwords.
Right.
They're the foundation for building truly robust, data-intensive applications.
They are. They're the principles that separate a system that's constantly breaking down from one that can handle anything you throw at it,
Yeah.
adapt to new challenges, and evolve with the changing tech
That's
landscape.
for sure.
And it all starts with understanding how these concepts work together, like a well-oiled machine.
Yeah, I love that. Okay, so I think that's a great place to stop for today. We've covered a lot of ground.
Yeah, we have.
But I think we're just getting started.
Just getting
We've
started.
got a lot more to unpack.
A lot more to explore.
So join us next time as we continue our deep dive into the world of data-intensive applications.
Sounds good.
And until then, keep those minds engaged.
Yeah, keep learning. Yeah, it's fascinating, isn't it? Kind of peering behind the curtain a little bit
Yeah.
and seeing like the intricate machinery that powers this digital world that we live in.
Mm,
And it's not just for, like software engineers.
right.
Anyone who uses these data-intensive applications, which, I mean, is pretty much everyone these days,
Yeah.
can
Okay.
benefit from understanding these fundamental principles.
I mean, it's kind of like knowing how your car works, right?
Yeah.
You don't need to be a mechanic to drive it,
Right.
but understanding the basics can make you a more informed and confident driver.
Absolutely.
You can anticipate potential issues,
Yeah.
maybe even do some troubleshooting yourself.
Exactly, and it can help you make more informed decisions
Yeah,
about the tools and services that you use
right.
and kind of understand the trade-offs involved in different approaches.
Yeah, okay.
So, for example, if you're choosing between two cloud storage providers,
Okay.
you might consider their approaches to data replication and fault tolerance.
Okay, that makes sense.
Yeah,
So we've explored these core concepts of reliability, scalability, and maintainability,
yeah,
as outlined in Chapter 1.
yeah,
But this is just the tip of the iceberg, right?
it is.
What other fascinating challenges and innovations
Yeah.
kind of lie ahead in this world of data-intensive applications?
Oh, there's so much more to explore.
I bet.
One of the biggest trends that we're seeing is this increasing demand
Okay.
for real-time processing and analysis of data.
Okay.
So think about personalized recommendations on e-commerce sites,
Okay.
fraud detection systems that flag suspicious transactions in milliseconds,
Oh, wow.
or self-driving cars that need to process sensor data instantaneously to make safe decisions.
Incredible.
These applications require systems that can ingest and analyze massive amounts of data
Yeah.
in real time without any lag.
Wow, that sounds incredibly complex.
It is.
What kind of technologies are being developed to handle those kinds of demands? Is
Okay.
it all about building like even bigger and faster supercomputers?
While raw processing power is definitely important,
Yeah.
it's not just about brute force.
Okay.
We're seeing a rise in distributed systems
Okay.
where that workload is spread across many interconnected machines
Mm-hmm.
and stream processing frameworks, which allow for continuous analysis of data
Okay.
and it flows through the system.
Gotcha.
And of course, machine learning algorithms are playing a critical role
Right.
in extracting insights and making predictions
Yeah.
from this like sea of data.
It's mind-boggling to think about the amount of data
It is.
that's being generated and processed every second.
Yeah, it's incredible.
It seems like this world of data-intensive applications is in constant evolution,
It is, yeah.
driven by these like growing demands and technological advancements.
Absolutely.
So, what advice would you give to someone who's just starting
Yeah.
to explore this field?
Mm-hmm.
Where should they focus their attention?
Well, it's a very exciting field to be a part of.
Yeah, I bet.
I'd say the most important thing is to cultivate a deep understanding
Okay.
of the fundamental principles that we've talked about today,
Hmm.
reliability, scalability, and maintainability.
Yeah.
These concepts are like the bedrock of good system design.
Right.
From there, I would encourage exploring different technologies and approaches
Okay.
like cloud computing platforms, distributed databases,
Mm-hmm.
stream processing tools, and never stop learning.
Right.
The landscape is always changing, so staying curious and adaptable is key.
That's great advice. It sounds like this field is not for the faint of heart,
Yeah.
but for those who love to solve complex problems
Mm-hmm.
and push the boundaries of what's possible with technology.
Yes.
It's like being a digital architect, designing the infrastructure of the future.
I love that analogy.
Yeah.
And it's not just about building systems.
Right.
It's about understanding the impact they have on people's lives.
Yeah, for sure.
These data-intensive applications are shaping the way we communicate,
Mhm.
learn, work, and entertain ourselves.
Yeah.
It's a responsibility we should take seriously.
Absolutely. So as we kind of wrap up our deep dive into Chapter 1 of designing data-intensive applications,
Yeah.
what's one key takeaway you hope our listeners will carry with them?
I want listeners to kind of walk away with this like newfound appreciation for the complexity and importance of designing these data-intensive applications. Well, these systems are like the backbone of our digital world.
Yeah.
And understanding the principles behind their design can help us make, more informed decisions about the technologies that we use
Right.
and just kind of appreciate the incredible work that goes into making these systems work seamlessly.
Yeah, that's a great point. It's easy to take these systems for granted
It is, yeah.
because they just work,
They
right?
just work.
But there's this whole world of innovation and ingenuity behind the scenes,
Yeah.
working tirelessly to keep our digital lives running smoothly.
Yes.
It's like this hidden city, like humming with activity, powering the experiences we rely on every single day.
And it's a city that's constantly growing and evolving, too.
Wow.
I encourage everyone to just stay curious.
Yeah.
Keep learning and explore this fascinating world of data-intensive applications.
Yeah.
You might be surprised by what you discover.
So for our listeners who are thinking like, okay, this is all very interesting, but what does it have to do with me?
Right.
I challenge you to think about like the last time you used social media,
Yeah,
shopped online or streamed a movie.
absolutely.
Every one of those experiences relies on these data-intensive applications.
It does.
Working behind the scenes.
Yes.
Yeah.
And knowing even a little bit about how these systems are designed
Right.
can kind of change the way you interact with them.
Yeah.
You might start to notice things you never did before.
Oh, yeah.
Like how quickly a website loads,
Right.
or how smoothly an app handles a sudden influx of users,
Right.
or how easily a platform adapts to new features.
Yeah, that's fascinating. It's
Yeah.
about becoming like a more informed user
Yeah.
and appreciating this like invisible world of technology that kind of shapes our daily lives.
Yeah.
It's like learning a new language.
Yeah.
Suddenly you can understand the conversations happening around you,
Right.
even if you don't speak it fluently.
Exactly.
I like that.
Here's a thought to ponder.
Okay.
The next time you encounter an error message,
Okay.
instead of getting frustrated, try to think about the system's attempt to maintain reliability.
Oh, okay.
Or when you see a new feature roll out on your favorite app,
Yeah,
consider the work that went into ensuring that system evolvability.
that's a great point.
Yeah,
These concepts are all around us if we know what to look for.
they are.
And the more we understand them, the more we can appreciate the incredible ingenuity
Yes.
that goes into building the systems that we rely on every single day.
Absolutely.
So keep exploring, keep questioning,
Yes.
and keep diving deep.
Keep diving deep.
There's always more to learn in this fascinating world of data-intensive applications.
Right.
It's like those hidden support beams in a bridge.
Right.
You might not see them, but they're crucial for holding everything together.
That's a great way to put it. And just like those support beams need regular inspection and maintenance.
Right.
So do these data-intensive applications.
Yeah.
It's an ongoing process of monitoring, adapting, and evolving to meet the,
Yeah.
ever-changing demands of the digital world.
So thinking about those three pillars that we discussed,
Right.
reliability, scalability, and maintainability,
Yeah.
what's like a real-world example of a system that excels in all three areas?
Well, a great example is like the Google search engine.
Oh, yeah.
Think about it, right?
Yeah.
It needs to be incredibly reliable,
Mhm.
handling billions of searches per day without fail.
Yeah.
It needs to be massively scalable,
Right.
able to accommodate spikes in traffic
For sure.
and ever-growing indexes of web pages.
Yeah, it's crazy.
And it needs to be highly maintainable,
Mm-hmm.
constantly evolving with new algorithms,
Right.
features, and security updates.
Yeah, it's easy to take Google search for granted because it just works so seamlessly.
It does.
But behind that simplicity
Right.
is just like a mind-boggling amount of engineering.
Exactly. And that's what's so fascinating about this field.
Yeah,
These seemingly simple interactions that we have with technology
right.
are often powered by these like incredibly complex systems
Yeah,
working tirelessly behind the scenes.
it's really amazing.
It's like an iceberg, right? What we see on the surface is just a tiny fraction of this like vast structure beneath.
So as we wrap up this deep dive into the fundamentals of data-intensive applications,
Yeah.
what's one final thought you'd like to leave our listeners with?
I would encourage everyone to embrace a mindset of curiosity and exploration.
Okay.
Don't be afraid to kind of peek behind the curtain and learn a little bit about how these systems work.
Right.
It can empower you to make more informed decisions about the technology that you use
Yeah.
and appreciate the incredible ingenuity that shapes our digital world.
Right.
So the next time you're using your favorite app or website,
Okay.
take a moment to consider the, intricate dance of data,
Yeah.
algorithms, and engineering that's
Yeah.
making it all possible.
That's a perfect note to end on.
Yeah.
Thanks for joining us on this journey through the foundational concepts of data-intensive applications.
It was my pleasure.
We hope you've enjoyed this exploration and learned something new along the way.
Me too.
Until next time, keep those minds engaged and those digital adventures exciting.
Yeah, keep learning.